Hello, and in this video we're going to talk about we're going to continue on with the section on quadratic functions, but we're going to talk about two examples that might come up and show you how to work through those examples. So we're going to do a couple modelings with quadratic functions. We ended up in the last section doing one where we had to find the vertex, and we had a problem where we worked out the height of an object when we had some function that modeled the ball being thrown. Now we're going to look at some things that may not be as obvious for quadratics, but they're going to also be used using quadratic formula to solve. So this first example says we have this pen that has fencing around it, has two separate fencing sections, and you have 500 feet of fencing to work with, and you want to make the maximum area in here so that you can maximize the area of this shape. Now this is probably a quadratic because we're dealing with area, and area on this case is length times width. Length times width equals area of a rectangle. Now we're going to be maximizing the area of this whole thing, so we're going to have to separate it into lengths. Let's say lengths here and widths here. So this is length times width. That'll be the area of the total shape, and that's what we want to maximize. So that's going to be a parabola. Probably, if we're going to maximize that parabola, or the quadratic, is going to look like this so that we can maximize. That means our a has to be negative in this function that we're doing. So let's make sure that happens when we're writing this. So what were we given in this thing? We have 500 feet of fencing to work with. So that's really not an area, that's a perimeter. So that's adding up all these things here. Well, this side is L also, this side is W, and this piece in the middle would also be W, because that's a width of the rectangle. So basically we're going to have two L's and three W's that equal 500. Now we need to write this function, area, in terms of length and width, with one variable. So we need to make this one variable here so that we can solve it. Now, in order to do that, we're going to use this perimeter fencing information to figure out what L or W is, and then we can just have one variable here. So I'm going to solve for L here. 2L equals 500 minus 3W, and L equals, let's divide by 2, so that's going to be 250 minus 1.5 W. If we divide both of these by 2, okay, now we're going to put that in here for L. So my area function now is going to be, instead of L, we're going to put in 250 minus 1.5 W for L, and then we're going to have that multiplied by W. So we're going to have a function here that is a quadratic, because if we multiply it out, we get 250W minus 1.5 W squared. We have this thing here, and if we rewrite it in standard form, it's going to be minus 1.5 W squared plus 250 W. In standard form here, this is A, this is B, and C equals 0. We don't have a constant value out here. So then we can find out where this maximum might be. We need to find the vertex. So we need to find the vertex of this thing. Okay, so our vertex is going to be a W value, because that's what we're finding, a W. We're going to do minus B over 2A. Our W value is going to be minus 250 over 2 times negative 1.5. Okay, so that's going to be a positive value. This is going to be 3 down here, so it's going to be 250 divided by 3, and that will be about 80. 250 divided by 3, which is approximately 83. Well, it is 83 and 1/3 actually, equals 83 and 1/3, or 83.3 repeating. Okay, so that gives us a width of the thing. So that means that this is 83. Okay, so the width equals 83 and 1/3. And let's see what we're dealing with here, feet. And then we want to find out the length. Okay, and now the length is, the length is a function of the width. We can just plug that in to figure that out. Or we have this function right here that says the length is 250 minus 1.5 times w. So we also have that. We can also plug it back into this function right here for w. That actually will give us the area, won't give us the length. So we need to actually use this equation. So let's do that. So the length is 250 minus 1.5. It's not moving around. It's moving around a little bit on me. Let's try erasing here. 1.5 times 83 and 1/3. Okay, that's going to be 125. So basically, we have 125 here and here, and 83 and 1/3 here, here, and here. Okay, so the overall dimensions is 125 feet by 83 and 1/3 feet. That should give us our maximum area, and our maximum area would be would be 10,416 and 2/3 feet squared would be the area, if we wanted to know that. I think they just wanted the dimensions, so we found the dimensions right here. Okay, so that was my first example. Here's a second example of something we might run across. It is also an area problem. Area, let A represent the total area. So we're multiplying two dimensions. That's usually going to be a quadratic. All right, so we have a wire that's 71 centimeters long, 71. We're going to cut it into two pieces. So let's say this piece is x, and this one is 71 minus x. One piece will be bent into the shape of a right triangle, the other one with legs of equal length. So let's take this one and we're going to bend it into a triangle. It's a right triangle. We're going to have all the total things here will be x. This is not really a true drawing because the legs are the same length. Okay, so this is, let's say these are both L for legs. L and L. Okay, so the other piece is going to be bent into a circle. So we're going to bend this one into a circle. Okay, so what you need to do is we need to figure out this three sides are going to equal x, and this circle circumference is going to be equal to 71 minus x. So the circumference equals 71 minus x here. And then that's going to be, the circumference is by formula on a circle related to the radius. It's 2 pi times the radius. So that's going to be the circumference. Now this one we have to have a perimeter of this triangle. So we're going to have to figure out this side, because that's going to add up to x. We'll have 2l plus the hypotenuse is equal to x. We need to figure out what that is. Now, we know this is a right triangle, so that means we have the Pythagorean theorem, a squared plus b squared equals c squared, and a and b are both l's, so we have l squared plus l squared equals c squared, so we have 2l squared equals c squared, so it's going to be the square root of 2l squared, or the square root of 2 times l. So that's what's going to go here, square root of 2 times l. So that's what's going to equal the x value here. Now, we need to find the area. Okay, we know the circumference, it's related to those two things. We need to find the area formula, because that's what we have to maximize or minimize area. So area here, let's do this one. Area is, in this shape, it's going to be 1/2 the base times the height, and that's L times L. The area of this shape is pi times r squared. Well, we need to make this in terms of x, because we need to know how it's termed in this function. So what we have to do here is we have to solve these up here for L, so that we can put it in here for L. We need to have x's in these two spots. Okay, so let's do this one first, r. So I'm going to change, here's my equation over here that has r. Now I need to go r equals, now I need to divide by 2 pi here to do this. So r is 71 minus x divided by 2 pi. Okay, so that's what's going to go in here. So that part of it is going to be we don't know what this is yet. Pi times 71 minus x over 2 pi squared. So we know what that is. This is r. Now we're going to have to figure out what L is here. So I would factor it out. There's L here and L here. I'd factor out an L. And that's 2 plus the square root of 2 equals x. And then x is going to be that, L is going to be x divided by that. So L equals x divided by 2 plus the square root of 2. Okay, so we're going to put that in there. As L. Now, some of this we can simplify. We're going to use technology to try to solve this for us, because we're looking for, this is pretty complex. This is a complex equation that we have to maximize or minimize. I'm not going to want to multiply all of this out. I'm going to use some technology to figure out the vertex from Desmos, and we'll get it from that answer. So, but I would want to simplify this before I have to type this whole thing into Desmos. So I'm going to square both of these. Let's see, if I square this, I get x squared, and then the bottom I get 2 plus the square root of 2 squared. Alright, if I square this one, I get 71 minus x squared, and then on the bottom I get 4, because 2 times 2, and then pi squared. oops, pi squared. Okay, we can reduce that a little bit. So let's rewrite this. This is a mess as a problem. So I have 1 x squared, or I can just put x squared over 2, 2 plus the square root of 2 squared, plus, now these are going to drop out, one of these, so I'm going to have 71 plus x squared, or minus, sorry, 71 minus x to the second power, and then this is going to be 4 pi down here. Okay, so let's type that into Desmos and see what we get for a maximum, or we should get a minimum. So this has got to be a positive. Hopefully it's going to be a minimum. Let's look at this in terms of our Desmos here. Here's Desmos up here. I'm going to move this down a little bit so I can see it still. But type it in. Maybe I'll move it over here. So we're going to have x squared divided by that 2. Okay, so let's go back and forth here. So y equals x squared divided by, and oops, divided by parentheses. We need to put this all in there. What do we got in the bottom? 2, and 2 plus the square root of 2 squared. 2 plus the square root of 2 . Okay, so they match up, but we don't see a graph. So what we need to do is zoom out here to see this graph. It's just very far out from the graph. There it is. So it is a minimum. There it is. So our value here is 46.133 for our x value. So x equals 46.133. 46.133. So that's our answer for the value of x. That's where we're going to cut the graph in, or cut the wire. So that's going to be 46.133, and then 71 minus that. Now it says, but we're got to answer the question, what is the circumference of the circle when a is a minimum? So we do know where we need to cut it, but we need to find the circumference. So the circumference, as we said, is 71 minus x. So basically our circumference is this piece. So what we did was we found x, but we need to find 71 minus x to get the answer. So that would be, we get 24.867. So this is going to be our answer because that's the circumference. This is the circumference of the, or the perimeter of the triangle, and then what's left over is the circumference of the circle. So, and that's in centimeters. So centimeters is our answer. 24.867 centimeters is the circumference of the circle.